Hi, I'm Nick Cato. I'm a system administrator with TGS. Jose has already covered what we do at TGS, and that's great because I was just going to have a picture of ultrasound, and the Earth was going to be the lady's belly. So it's much better explanation. So Panasas has asked us, along with I think 2 or 3 other clients, to evaluate the UltraStore platform. That's the name we're going with. Okay, that's no. Oh, that's ActiveStor. ActiveStor Ultra Bay. Okay. Here's some of our results and what we got to. Okay, first, history of TGS with Panasas. Fortunately, Jose already covered most of it. We became a Panasas customer in 2004. We currently have 22.738 petabytes of Panasas installed. Yeah, slightly off. I can say, Jose says we're going to have 120 next year. We have 22 now. Last year we had 18. The year before that we had 8. So, right, it's going right up. We actually do run many other storage types, but Panasas is our primary production storage just because the other ones are just for holding data, not processing it because they can't. Okay, if you're familiar with installing a Panasas shelf, you may know that each one includes a souvenir collectible screwdriver that you're allowed to keep and trade with your friends. That is actually one of like 3 or 4 drawers we have full of those. And I've got one at home too. So let's see. Yeah, we actually run several different other vendors that I won't mention, but none of them are good enough to be on this presentation. Okay. So a little bit about my history. I started with TGS at 2006, and almost immediately after beginning with TGS, Panasas became a large part of my responsibilities. That means deployment, monitoring, administration, support from the minute it hits the dock to box cutter to everything, even to retiring it and salvage and having the salvage guy come take it away for recycling, right? I have a lot of people that help me, but it's my primary responsibility. So because of that and because of Panasas' long history with TGS, I kind of calculated it, and I don't know, maybe somebody in this room, but I may be the world's most experienced Panasas installer, and the most modest. And just, I also test, as Jose said, 2 or 3 different storage vendors a year. Sometimes I'll test 5, sometimes I'll test 1. And I see it as not only useful for us so that we can see what's out there and keep our finger on the pulse of storage, but it's useful for them because afterwards I always give them feedback and tell them what they did wrong. So those tests also include Panasas products. It's not, I think I've tested just about every new hardware revision that they've come out with in these 10 years. So not only am I the world's most experienced, but I'm also training the world's youngest Panasas installer at 10 years old. He loved it, by the way, so thumbs up from him. Okay, first of all, I want to give a little retrospective on the existing hardware that you guys are familiar with. I have always described it as elegant, and let me tell you what I mean by that. It's modular, it's user serviceable. There's nothing inside there that's magic, right? In fact, if you open most of the revisions, you know, you look inside and you're like, well, it's not even a very powerful processor. It's not a very amazing hard drive. It's, you know, there's nothing that's extraordinary in there until you apply the software, which brings it all together in a collective and basically creates HPC in a tiny scale, you know, and gives you that sort of benefits of HPC, but on a tiny scale. Just about everything inside is either redundant or it's not mission critical. I can blow a drive, no big deal. Don't call me on Saturday, right? I can, you know, lose a power supply. I'll get an alert. Okay, well, I'll look at that after lunch, you know, not a big deal. Anything that does break, I can swap out in 10 seconds. I don't have to, you know, I could do that live. I don't have to take it apart. I don't have to call some flunky from Unisys who's watched like one training video and schedule for him to come in for 2 hours and sit there and, you know, cut himself on my motherboard and bleed all over the place. As a matter of fact, the only thing that is not easily user replaceable is the shelf chassis itself and the backplane. But if you look on the backplane, there is one ceramic capacitor on there, and I've never seen that thing go out. You can, in theory, break one of the connectors, but if you're going to do that, you're going to do that during install. Well, I did one time. Was it my fault? Well, it was kind of my fault. There's also been flexibility into fitting into different customer networks. You know, the switches on the back have, for a small switch, has a lot of flexibility as to what you can plug into it. That is changing, and I will get to that in the next one. I also want to give a big thumbs up to your guys' shipping department and your RMA department. That's something a lot of vendors overlook. All the boxes are custom made. They have exactly the amount of packing material I need and not too much. There's not a whole bunch of useless paperwork in there I gotta throw away. I don't have to bother anybody to get a shipping label. If you've ever dealt with other vendors, you know that is often a case. They act like shipping things is something that's not their responsibility. But here I can, you know, do an RMA, and if it's by the cutoff, I'll get it the next day or the day after that, depending on how well FedEx is doing, right? And then I've got a new part, I slap it in, 10 seconds later I'm ready to go. Okay, so the new hardware, it's a lot different. I'll tell you that. I was a little skeptical at first. It took me a little while to warm up to it. The first thing that I think is a great benefit is the network infrastructure. Those little switches they had in the back were great, were very powerful for their size, but there's only so much they could do, and they were reaching the limits of what they could do. So Panasas was smart. They outsourced that to a network vendor who's got a lot more experience and can worry about all that network BS for them, right? And they use the benefits in their product. We now, because of the upgraded network infrastructure, have out-of-band recons, right? Big deal. Every other vendor makes a big deal about, oh, we have out-of-band recons, blah, blah, blah. The truth of the matter is if you have a big boy network, it doesn't matter because the recons are going to go fast enough that it's not going to be an issue. The individual ASUs are now much smarter. Now when you open them up and you look at the hardware, you're going to say that's pretty beefy, right? I like that because not what it does for me now, but what it's going to do in the future. I look at all that horsepower and I say, they've got something planned for all this horsepower. I know they're going to do something with it. He's smiling over it, isn't he? As Jose said, we don't really use any sort of I/O middleware in any of our software, right? It's been a chore, but it doesn't fit well with our workflow, right? This is an opportunity. Maybe you guys are thinking about that. I don't know, just kind of putting it in there, right? We don't use Darshan, we don't use MPI/IO. We're strictly parallel. Oh, the best part, no more batteries. The only part I didn't like about the hardware of the old architecture was the batteries, because they're big, they're heavy, and they're covered in sharp edges. And I got a lot of cuts in my hands from those batteries. I also know that you guys probably didn't like them because they're expensive to ship, even though they're not expensive to make. So you've got something that basically costs you guys more than it is probably worth to ship back and forth to me when I break one, right? Okay, well, that's actually the eval, but I want to talk about what the production scale integration would look like for us. First of all, we're going to need a bigger rack. We put it in, and the first thing I noticed was that the cabling on the back end, it's a little bit hairier than it used to be. It all fit. We use these very cheap Dell racks. They're not full depth racks. We've been getting away from using them. So the first thing I said, well, I'd like a little more space in the back. The second thing I noticed was, you see right there, that's where the hinge is, because I had to take the door off, because all those tabs on the left don't fold in like the other ones do. So the first time I tried to close the door, I almost broke the tab off. So definitely going to need a different rack. In a production deployment, we would probably use 8 ASU chassis, 1 ASD chassis, the switches. and possibly the drag, what do you call it? Drag, it's not called a drag. You guys are calling it the BMC switch or something, the administrative switch. I don't know how strictly necessary that switch is. I do know it came in really helpful for the eval because we were doing a lot of funny things with the hardware, but I've still got room for it basically. And at 37U, if we only used 8, that would give us about 1.9 petabytes per rack. It's pretty good. We could add another one, right? Take it up to 41. But what's really impressive about that is it gives us 60 terabytes NVMe, right? I know you guys are going to make use of that. Okay, all right. We would also probably go with 400 gig uplinks, but that's just us. The good news is that because you've got those Mellanox switches now, you can literally do anything you want. You can do copper, you can do 40 gig, you can do 10 gig, anything except token ring, because if you're on that, you're in trouble. So here's what the eval actually looked like. I mean, you saw a picture of it right there in our data center. Don't pay attention to stuff above that because that's another. So we had one ASD chassis with 2 active ASDs, and then one of them was actually a Linux box they were using for extra testing. And we had 3 ASU chassis with 4 each, and we had the 400 gig uplinks with the switches. We tested ActiveScale through, oh no. Attempting to access my information.
That's my phone.
Oh. We went from 8.0 all the way to 8.3. We actually did the 8.3 update last week. There we go. How do I test it? Well, okay. I'll tell you the truth is we're not really done testing. And there's a reason for that. The first reason is we've been extremely busy production-wise, and I have to borrow resources from production to do testing. The second reason for that is this hardware has progressed long past the point where usually things fall over, so now I need more time to do the testing and I need more resources. So I guess that's a good thing. The first thing I generally do is some basic throughput testing with DD. I push 950 nodes against it. Usually I will start with 200 and then do another 200 and 400 and 500 and 600. In this case, in the interest of time, I just went ahead and did them all. Typically, we will see vendors fall over in the 600 to 700 range, depending on what they bring us. This one went all 1,000 nodes, did great, gave me 7,100 megabytes a second, sustained. Disk activity at 95%, which is what I like to see. It shows me that disk is working pretty good. It's a very simple test, though. It's single-threaded. It's not doing anything funky like trying to cross-read files, doing one-to-many or anything like that. This is just me kicking the tires. But I can tell you right out of the gate, 3 shelves, you wouldn't get close to that, right? 3 shelves of the old gen. If you consider this on a shelf-by-shelf basis, which I know they wouldn't, but I do because it takes up the same amount of space in my rack, that's already, and I barely started testing, and I've already gone past the mark. So after that, Ellis asked me to do some Ozone testing. I said, great, give me the details, what you want. You guys want to write that down? It's right up there. On this one, I was only using 192 nodes, but as you'll notice, this Ozone test is a lot meaner and a lot more stressful than the previous test. We got to, actually, you see the first little bump right there? That was me testing with, I think, 20 some odd nodes, just to make sure I had the arguments correct. And then in the actual test, we got up to 6,000. We think that's because we pretty much hit the network limit of the nodes we were using to test, right? All of these nodes go to a top-of-rack switch, and the top-of-rack switch then uplinks to the main core, and Panasas plugs into the main core. Then we got a little dip here, and then you'll see that above. You say, well, how did you exceed the network of the clients? Well, that's because that's inter-realm activity sort of making up for the dip there. So I don't consider that a bad thing. I'd say that's good. It was pretty impressive. As Jose said, in recent memory, only one vendor has gotten to that level. I will also tell you that that vendor used a lot more spindles. So I don't really consider that an apples to apples comparison. Most other vendors will fall over much sooner than this, but I say that's good for them because we get to tell them where they went wrong. So your most important point is I have not broken it yet. I will break it at some point, I hope, probably. But the problem is that with that is I only have so many nodes available. I can take them from, production, but only with their blessing. The closest competitor I've tested is just close, and with many more spindles. I will say that it's probably going to take a significant amount of our existing cluster to push this particular eval to the limit. And I believe we have also planned on adding an extra ASU to this eval, in which case it's really going to take a lot of our cluster to push it to the limit. Now we get that bigger cluster, we get it done. Failure testing. I did everything. I pulled an ASU chassis power supply, pulled a 4 gig connector, pulled a 1 gig Ethernet management, pulled a hard drive from an ASU. That's when I learned that if there's actually no activity on the realm, the system will not go into recon because it's not actually being asked for that data. I like that idea because that means it's possible that even if a hard drive gets pulled out, it's not a problem. Somebody mistakenly puts it back in. Me, probably. I also unseated an entire ASU just for fun, but I will say that if you've got entire ASUs being pulled out by somebody, you got bigger problems than a recon. I like not having to worry about getting calls on the weekend, and that's the best thing for me about Panasas, is that yes, things can go wrong, but the system usually recovers, and it usually recovers on its own without my intervention. Often my intervention is probably just going to make things worse. I can deal with it on Monday when I come in on the Monday if I get a call on the weekend. I also know that, having worked with them for 10 years, there's been bugs and issues that have hounded us for years, but we've gotten to the point now where typically if a processor comes to me and starts complaining that, hey, my jobs are running slow, and he's the only one complaining, I know it's him. I know it's not the system. Because a lot of people use these systems, if you're the only ones using it and you're the ones complaining, well, you've probably built your job wrong, you're trying to do something wrong, you're trying to push 5,000 nodes against 5 1 gig files. And at that point, it's not my fault, it's your fault. So I would say in the past where probably 80% of the problems were technical issues, I would say now probably 15% of them are technical, and the rest of them are I have to go to their manager and point out how they built the job wrong, or how they've forgotten to do something. So that's it. Any questions? I'm glad I went fast enough nobody could ask questions.
Anything from Nick? Thank you, Nick, and thank you for all the work you did on the beta. We appreciate it.